Okay, I got the Measurements Corp, Boonton, they call it Boonton Corporation, the Model 59 from 1959 grid dip meter, and seems to be working. In other videos, I showed how I cleaned this all up and tested the calibration. All the coils are spot on except for one coil, the 22 to 45 megahertz is reading a little high. That's the one that the top cover was pushed in a little bit. The other ones are dead nuts on. As far as the dial, I calibrated the dial with these slotted screws, which changes the faceplate, which adjust that frequency to the frequency readout on my scope, which also has a little frequency counter right there. And I had this coil that I had made up that was sitting on my messy bench for a long time. I got this cap from John, this infamous little red cap. We measured, he measured 30 picofarads. I measured it here as about 28 picofarads. So in a parallel tuned circuit, and I measured that coil was about 5 microhenries, 28 picofarads. Frequency is 1 over 2 pi squared root LC, comes out to about 13.45 megahertz. So we're going to test this baby. So we put this near the coil, and we watch the grid meter, and we're going to find and see if it dips. And there she goes. It is extremely sharp. I mean, it is so sharp. I just don't think that I could get this on here. Now notice that this, when it does resonate, you'll see the amplitude go way up, and then it just jumps out. Not sure why that is. So what I'll do is I'll try to find the dip here, and then stop and then see what that frequency is. So yeah, I just can't. It is so critical, right about there. Yeah, that's about. If I touch it anymore, let's see it. And then it jumps out. So let's see. Actually, when it dips, it actually diminishes. So, which makes sense because I think the coil is absorbing all of the frequency, the RF. So let's see. So the meter is. Boy, that is critical. But yeah, when it dips, the frequency goes away, or the amplitude goes way down. So what we'll have to do is increase the vertical sensitivity so we can get it to trigger. And then we'll see what the frequency is. And it's reading 14.7. So that's pretty close to what we calculated. Let's do this again here. See where it dips. Yeah, I'm just going to call that good. So 14.48, 14.5. And there's Phoebe. So 14.5 versus 13.45. Pretty close. So I'd say it's working. I'll move this off of here. I don't know if this scope is affecting it or not. I'll have to find out. I'll get it to dip again. Boy, it is sharp. Right there. And then what I'll do is just kind of very carefully put this over there. Whoop. That's not going to work real well. And it changes it a little bit. Whoop. Okay, what's going on here? Boy, that is sharp. Okay, let it go. Same thing, about 14.5, 14.4. So there we go. It seems to be working for the most part.